Hi everyone, welcome back to the next video in the tutorial video series. In this video, we're going to be having a look at the week 6 tutorial question, question 4, which is going to provide an example of how to perform a one sample proportion test. Okay. All right, so question 4 is asking us, or rather, telling us that we are to assume a real estate analyst believes that more than 50% of homes are in outer suburbs, defined as more than 20 kilometers from the CBD. We're going to test this claim using a one sample proportion test, and we're going to use that four-step procedure that we've been using to go through systematically with our response. And we basically just want to answer this question, is the proportion significantly greater than 50%? Okay. So the first thing that we're going to do before we go ahead and actually perform the test is we need to construct a dichotomous variable that indicates if a particular house in a data set is more than 20 kilometers away from the CBD. Okay. I'm going to call this new variable outer suburb. It's going to indicate if they are in fact an outer suburb house. And we're going to use the if formula as a way of doing this. So it's going to be equals if some particular house is greater than 20 kilometers, so 20,000 meters, we're going to put a 1. Otherwise, we're going to put a 0. Close bracket. When we're happy with the formula, let's just drag it down. There we go. We have indicated which of these houses are more than 20 kilometers away. Okay. All right. So the next thing we're going to do is we're going to go through our four-step procedure. The first step being step 1, to state the hypotheses. So we're going to have HO and HA. Particularly when we're dealing with an inequality in our hypotheses, and in this case, we want to know that we're told the real estate analyst believes more than 50% of homes are in outer suburbs. It's best to write our alternative hypothesis so that this is the claim we're trying to find evidence in favor of, rejecting the null in favor of this. So we're going to start with our alternative, which is that we believe that, or we want to test that more than 50% of homes are in this outer suburb. So we're going to write this as P greater than 50% or 0.5. Our null hypothesis is going to be the complement of this. So P is less than or equal to 0.5. All right. Next, what we're going to do, step 2, is we're going to state the decision rule. Decision rule, this is basically the criteria that we're going to use to reject or fail to reject the null. And this is just the statement. If the p-value is less than 5%, some level of significance that we can choose, it's not given to us in the question, so we're going to take 5%. Then we reject the null in favor of the alternative. Okay. Step 3. This is going to be our validity checks and our analysis. Now, there's 3 things we need to do here. We need to choose a method. And choosing a method should follow from the way that we've written our null and alternative. We're dealing with a proportion in our null and alternative, which means we're dealing with some type of proportion test. And there's only one sample, right? We're testing it for one group. So we're dealing with a one sample proportion test. Okay. Now that we have our particular method, we can actually go ahead and perform the test, right? Or sorry, like not perform the test. Do the like validity checks before we get into it. Okay. The validity checks for a one sample proportion test are that n times p and n times 1 minus p are both greater than or equal to 5. Okay. This basically ensures that the sampling distribution for our proportion is approximately normal, which we need in order to calculate the p-value for this test. Okay. So we need our sample size, which is n, and we're going to need our proportion. But in order to get our proportion, we're going to need the number of successes. Okay. So sample size is quite straightforward. We're going to use the count formula. The number of successes is also pretty straightforward. Because we've set this up as zeros and ones, the number of successes is just the sum of this range, okay? Because it's only going to include those that are equal to 1. Okay, so 114. Then for our proportion, successes divided by sample size, 0.258. So now we can do our validity check. Sample size times proportion, that's bigger. And sample size times 1 minus the proportion. What you'll notice is NP is just the number of successes, and N times 1 minus P is the number of failures, or the number of times that a 0 is in our list here. Something we might notice at this point is that our alternative hypothesis is that our proportion is greater than 0.5. We've just found a sample proportion, which is 0.258, right? Which is smaller than this hypothesized value, right? So what this means is that when we go ahead and conduct the test, we're almost certainly going to be failing to reject, or rather, we're certainly going to be failing to reject because our level of significance is 5%. Okay, but let's go ahead. Let's go ahead and use our template here. So using the template that's on the Canvas site is going to be the easiest way to go about conducting this test. There is no dedicated formula in data analysis toolpack, or no method there. So using this calculator is going to be the simplest way of doing it, unless you feel like going ahead and doing it manually. We're after a one sample proportion test, which we can find in the table of contents. And we're going to copy and paste this calculator over to our working file. And we're going to use the regular paste option to do this because we don't want to get rid of any of those formulas. Like the other calculators that are in this file, we want to make sure that we fill out these values here that are highlighted yellow, okay? And then the rest of the calculator will get filled out. The sample size is 441. The sample proportion, 0.258. Hypothesized value, 0.5. And the level of significance is 5%. Okay. Now there's 3 different tests that are getting performed here. The way that we're able to tell which of these we're after is based on either like 2 different methods. The first one is thinking about where our rejection region is, right? The rejection region lines up with how we've written the alternative hypothesis. So if we think about our alternative hypothesis being the proportion is greater than 0.5, if this is our sampling distribution with a mean of 0.5, right, then we would be rejecting in favor of this alternative if we found a sample proportion that was sufficiently large, right? And then it would be in this tail up here. So because this is where we're rejecting, what we're looking at is an upper one-tailed test, right? The other way to be able to tell, and this is something that's convenient about this calculator, is that it provides what the null hypothesis is for the test. So this is our proportion is less than or equal to some constant PO, which is what we have here for our null hypothesis. So what we're after is an upper one-tailed test. So this is our p-value. Okay. So we're going to write a quick statement. We're going to say because the p-value on a, sorry, let's just write out what our p-value is before we make the decision. We can say, therefore, the p-value is 1 or approximately 1. Okay. All right, step 4, make a decision, right? So this is where we apply the decision rule. We were told that decision rule, if the p-value is less than 5%, then we reject the null in favor of the alternative. This is not less than 5%, this is 1. So we can say because the p-value is not less than 5%, we fail to reject the null. Therefore, we do not have evidence to suggest that most homes in the data set are in the outer suburbs. Okay. It's also worthwhile to take a step back from this test that we've just conducted and think a little bit about this sample that we have, right? Um, one of the other conditions here is that our sample needs to be randomly sampled from our population. If we have a look at our data set and the actual types of suburbs that are here, Alfred Cove, Alkimos, Applecross, Alexander Heights, right? These are the first 4 suburbs alphabetically in Perth. Okay. So the sample that we have here, at least when it comes to where the suburbs are, right, is not randomly sampled. It's just the first 4 alphabetically. Okay. So there's no reason to think that the sample we have is representative, at least in terms of suburbs, of the whole population, right? So what that means is that maybe we shouldn't put so much stock in this conclusion and we shouldn't generalize it, right? Maybe our conclusion needs to be just for the houses that are in these suburbs, right? All right, guys. Thanks for listening. I'll see you guys in the next video.